Oh, hey everyone, it's Justin again. I had so much fun playing Power Play that I've been going back and replaying some of my favorite levels. Do you remember level 4? That was the one with the power of a quotient maze. Well, I found a hidden Easter egg in the game. Check this out. This is the second checkpoint of the maze. The correct answer would be to choose up, but if you input a certain pattern instead, it takes you here, Radical Beach. How cool is this? I wanted to wait and show you, so I haven't started playing it yet, but now that you're here, we can dive in.
Warning, high surf. In order to catch a wave at Radical Beach, you must be able to calculate and estimate the square root of given numbers.
I don't think we've learned about square roots yet, but I'm sure we can figure it out together. Let's do it.
Identify the matching sandcastles to clear the way.
Here's our first task. Match the sandcastles. Some have numbers while others have an expression with a number squared. How should we match them up? Pause here to make a prediction in your guided notes. Take your time to consider all the options. I noticed that there are 5 expressions and 5 regular numbers, so maybe each expression matches with a number. Did you try evaluating the expressions? If not, pause here to do that now. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. Oh, they're perfect squares. A perfect square is the product of an integer multiplied by itself, or an integer squared. For example, 9 is a perfect square because 3 times 3, or 3 squared, equals 9. Oh, there's another task in our way.
Complete the list of perfect squares. You'll need it going forward.
We've already discovered the first 5 perfect squares, but to get past this task, we need to list the first 15 perfect squares. Pause here to evaluate each of these expressions and complete the perfect squares list in your guided notes. Here's my list. Feel free to pause here if you want to compare mine with what you wrote in your notes. The game said we'll need it. All right, we made it onto the beach.
You need a surfboard to continue.
Well, I guess we need to head over to the surf shop.
Complete the shopkeeper's tasks to earn a surfboard.
Identify the pattern in the completed examples. Then use that pattern to fill in the missing numbers. This reminds me of those discovery activities we did earlier in the unit. Pause the video here to analyze these examples and determine the pattern. This first column seems familiar. Where have we encountered these before? They're perfect squares. In the next column over, each of those perfect squares is under this funky symbol. What do you think that symbol means? That is the radical symbol. And when there's a number inside, that number is called the radicand. This symbol is a type of mathematical operation, like addition or an exponent. But what do you think it means? In the first row, 2 squared gave us 4, the perfect square. Then 4 with the radical symbol
equals 2. In the next row, 3 squared equals a perfect square 9, and then 9 with the radical symbol equals 3. The same number that, when multiplied by itself, equals the perfect square. So this radical is like the opposite of squaring something. Using that information, what do you think should go into these two blank spaces? If 4 squared is 16, then working backward, 16 with the radical equals 4. Same for the one below. 5 squared is 25, so 25 with the radical equals 5. There's one blank left. We have 100 with the radical symbol. With the other examples, the answer was the number that, when squared, equaled the radicand. So what number could we square to equal 100? If you're not sure, check your perfect squares list. Yeah, 10. Wait, there's more. Whoa, this side has negatives. And hey, do these commas with another blank in the middle column mean there can be another answer? Pause here to consider this new information and try filling in the blanks similarly to how we did before. We'll talk through it together when you're done. This time, instead of 2 squared, we have negative 2 squared, which still equals 4 because we know a negative number multiplied by another negative results in a positive. So if positive 2 squared gives us 4, and negative 2 squared is 4, then the radical symbol over 4 equals positive 2 and negative 2. We see that same pattern in the row below as well. 3 squared equals 9, and negative 3 squared equals 9. So the radical symbol over 9 equals 3, or negative 3. We can continue that same pattern in the next 3 blanks. The radical symbol is an operation that tells us to calculate the square root of a number. Like we determined with those examples, the square root is the opposite of squaring. It's basically asking us what number, when multiplied by itself, or squared, will give us the radicand, the number under the symbol. Square root problems, like this one, have 2 answers, and you can write them in a few different ways. As -5 or 5, as -5 comma 5, or by using this fancy plus minus symbol before the number 5. The plus minus symbol indicates that an equation has 2 solutions, one positive and one negative. When you see the radical symbol, you read the expression like this. The square root of 25 is -5 or 5. The final task from the shopkeeper. Calculate the square root for each expression below. If you get stuck, use your perfect squares list to help. To calculate the square root of 64, we need to determine what number squared equals 64. 8 squared equals 64. -8 squared also equals 64. So the square root of 64 is -8 or +8. And the square root of 144? -12 or +12.
Nice! We got our surfboard!
In order to catch a wave at Radical Beach, you must be able to calculate and estimate the square root of given numbers.
Estimate the square root? There must be one more step. Let's talk to that NPC over there. Like gnarly waves, radicals can be just as unpredictable. You've been cruising with those perfect squares, but to truly hang loose at Radical Beach, you gotta work with the other numbers too. You know, that's a good point. How do we estimate the square root of a non-perfect square, like 22? What number squared equals 22? Is there a number that we could square to equal 22? I guess there must be, it just might not be a whole number. We're gonna end up with a number with a decimal, but how do we figure it out? Should we just start picking numbers with decimals and then squaring them until we get 22? There's a lot of numbers out there, like an infinite amount, so that could take a really long time. There must be some way that we can narrow down the options. Maybe that perfect squares list in your notes can help. Can you find any perfect squares that are near 22? There's 16, which is the closest perfect square less than 22, and 25, the closest one greater than 22. Maybe if we identified the square roots of 16 and 25, we can narrow down our search for the square root of 22. Pause here to record the square roots of 16 and 25 in your guided notes.
The square root of 16 is 4 or negative 4. And the square root of 25 is 5 or negative 5. So that means the square root of 22 must be somewhere between positive or negative 4 and 5. To make things a little easier, let's work with just the positive numbers right now. But we'll need to be sure to include the negative option in our answer when we're done. There's still a lot of numbers with decimals between 4 and 5. How can we narrow it down even further? Well, we know the positive square root of 22 will be somewhere in between 4 and 5, but where exactly? Should it be right in the middle at 4.5? Or do you think it'll be closer to either the 4 or the 5? Pause here to make a prediction in your guided notes. The number 22 is closer to the number 25 than it is to 16. So on this number line, we can expect to find the square root of 22 closer to the square root of 25. That means the positive square root of 22 is greater than 4.5 and less than 5. So what do you think? Pause here to estimate the square root of 22.
Do you have your estimate ready? I've got my calculator here so we can check how close our predictions are. Rounded to the nearest tenth, the square root of 22 is, drumroll please, 4.7 or negative 4.7. Be sure not to forget that negative option. I guessed positive or negative 4.8, so I wasn't too far off. Positive or negative 4.6, 4.7, and 4.8 are all good estimates for the square root of 22. The goal is to just get as close as possible, and don't forget to include that negative answer as well. So, to estimate the square root of a non-perfect square, we can identify the perfect squares below and above the number in question. From there, we can find their square roots and use a number line to estimate the answer. Why don't you take a turn at it on your own? Pause here to estimate the square root of 51 in your guided notes.
Were you able to determine the perfect squares closest to 51? 49 is the closest one below, and its square root is 7 or negative 7. 64 is the closest perfect square above, and its square root is 8 or negative 8. I'm just showing the positive options here, but we'll need to remember to include the negative option when we get our final answer. So the square root of 51 should be somewhere between 7 and 8. Right in the middle of 7 and 8 would be 7.5, but is 51 in the middle between 49 and 64? It's much closer to 49 than it is to 64. So its square root should be much closer to 7 than 8. Do you have a guess? If you guessed positive or negative 7.1 or positive or negative 7.2, then you got it. Keep in mind, this skill of estimating square roots takes practice, so it's okay if your guess was off by a little bit. The more you practice, the more you'll get the hang of it. It's sort of like surfing. Not everyone can just stand up on their first wave. Speaking of surfing, we learned how to calculate and estimate square roots, so we're ready to shred the gnar at Radical Beach. Hey, that's Expodox! Totally radical.
Oh, sweet, there's another Radical Beach level. Big wave surfing, cool. You'll want to complete the Radical Estimations activity and online practice before we jump into the next level of Radical Beach. Keep practicing, and I'll meet you back here for our next lesson and the next level of our game. See you next time.